Very good morning to all of you. This is mathematics class of grade 8 and this is lecture number 3 of chapter number 9, algebraic expressions and identities. Let us see today's topics. In this lecture, first of all, we will be recapitulating the concept of polynomials, addition and subtraction of algebraic expressions, and then the main topic of this lecture number 3 will be multiplication of algebraic expressions. I will be explaining how to multiply algebraic expressions, and further in this main topic I will be explaining the multiplication of two or more monomials and multiplication of a polynomial by a monomial. Dear children, I hope you must be remembering the definition of algebraic expression. What do you mean by an algebraic expression? A collection of constants and literals or variables connected by one or more operations of addition, subtraction, multiplication, and division is called an algebraic expression. And further in this chapter, we have learned about factors, constant term, like terms and unlike terms, and few concepts we will be revising in this chapter. As I told you earlier, that we will be revising the concept of polynomials, addition and subtraction of algebraic expressions. So let us recall now. What do you mean by a polynomial? An algebraic expression is called a polynomial if the powers of the variables involved in it in each term are non-negative integers. So what do you mean by a polynomial? An algebraic expression is called a polynomial if the powers of the variables involved in it in each term are non-negative integers. Then we can say that the given algebraic expression is a polynomial. It means you are supposed to check the powers of the variables involved in every term of that expression, and the powers of the variables should be non-negative integers. Then you can easily say that the given expression is a polynomial. Next point to note about polynomial is a polynomial may contain any number of terms, one or more than one. Now, further we have learnt about the degree. What do you mean by the degree of an algebraic expression or the degree of a polynomial? To find the degree, we need to take the sum of the powers of the variables in each term, and the greatest sum is the degree of the polynomial. So, first of all, you need to find out whether the given expression is a polynomial or not. If so, then only you can tell the degree of the given polynomial. First of all, you need to check the powers of the variables. Here in this expression, x is the variable present in the first term and 5 is a constant term. And what is the power of this variable x? It is a non-negative integer, so it is definitely a polynomial, and degree of this polynomial will be clearly 1, because here the only variable present is x and the power of x is 1, so the degree of this polynomial is 1. Now coming to next expression, the terms are 8x square y minus 7xy square plus 9xy plus 3. This is a polynomial of 4 terms. Here, how many terms are present? 8x square y is the first term. Second term is minus 7xy square. Third term is 9xy. And 3 is the fourth term. Now, we need to find whether it is a polynomial or not. As for a expression to be a polynomial, the powers of the variables present in every term should be non-negative integers. Here in the first term, that is 8x square y, the power of x is 2, power of y is 1, and these are non-negative integers, so it is satisfying the condition of polynomial. Coming to second term, here the power of the variable is x is 1, y is 2. So it is, these are also non-negative integers. So it is again satisfying. Likewise, in the third term also, the power of x and y both is 1. So it is again satisfying the condition of polynomial. And the last term 3 is a constant term. So this is a polynomial. Now we need to find the degree of this polynomial. First of all, in the very first term, that is 8x square y, what is the total of the powers of x and y? It is 3. Now, if I talk about second term, that is minus 7xy square, what is the total of powers of x and y? It is again 3. Coming to third term, that is 9xy. Here the powers of x and y both, what is the powers of both x and y? That is 1 and 1. So total is 2. And which is the greatest number out of these 3? So 3 is the greatest number and the degree of this polynomial is 3. Now coming to third example, first of all you need to check whether it is a polynomial or not. If it is not a polynomial, we will not be able to find the degree of that polynomial. So first term is 9x, here the variable present is x. What about this second term, that is 3 by x? Here in this 3 by x, it can be written as 3x raised to the power minus 1, and the power of x is a negative integer and it is not satisfying the condition of a polynomial. So we can say that this is not a polynomial. I hope this is clear to you. Now coming to the addition of algebraic expressions. Dear children, while adding two algebraic expressions, we need to add or take the sum of like terms, as it is written over here. The sum of two or more like terms is definitely a like term with the numerical coefficient equal to the sum of the numerical coefficients of all the like terms. Simply you are supposed to find the like terms and then simply add the like terms together and get the answer. Now to add two or more algebraic expressions, two methods, in the two ways we can solve this. It can be horizontal method or column method. It is up to you. You can use any of these two methods. For example, I need to add these three expressions. First of all, I'm making you recall the horizontal method. In this, simply you're supposed to write the expressions the way I have written. I have written in a horizontal manner, that is why it is a horizontal method. I have written the first expression, then plus sign, second expression, then again plus sign, and then third expression. Simply I need to write the like terms together and then I will be able to get the required sum. So in all the three expressions, I have seen that these are the like terms to be written together. These two are like terms. After solving, I will be getting minus x square. These three are like terms. After solving, I will be getting minus 7xy. These three are like terms. Then after solving, I will be getting the sum of these three like terms will be 12y square. And minus 1, 5 and minus 13, these are like terms. And after solving, I will be getting minus 9. So the required sum will be minus x square minus 7xy plus 12y square minus 9, and which is our required sum. This is your horizontal method. If I will be solving this using the column method, my answer will remain the same, but the method of writing the question will be changed. Like I am showing you, this is the column method. In column method, you are supposed to arrange the like terms in such a way that they are one below the other. Like in the first expression, 3x square, it is the first term. So I have written in second expression, there was no term of x square. So I have leave the blank. And then in the third expression, minus 4x square was the term. So I have written these two one below the other. Likewise, every term, every like term of all the three expressions are to be written one below the other, and after solving you will be getting the answer as minus x square minus 7xy plus 12y square and minus 9. Now subtraction of algebraic expressions. To subtract algebraic expressions, we need to change the sign of each of the algebraic expression to be subtracted and then add. Like, to subtract algebraic expressions, change the sign of each of the algebraic expressions to be subtracted. Whatsoever is the algebraic expression to be subtracted, we need to change the sign of that and then add. In this subtraction of algebraic expressions, again I can use any of these two methods, horizontal method or column method. So I need to subtract 5x cube minus 3x square minus 8 from 2x cube minus 5x square minus 11x plus 2. Firstly, I am showing you the horizontal method. As I need to subtract 5x cube minus 3x square minus 8 from this expression, so this will be written first minus the first expression. And as I told you, the sign of every term will be changed, which is written inside the bracket. So here you must have seen that the sign of this expression has been changed. Earlier it was minus sign here, now it is plus sign. Here it was minus sign, now it is plus sign. You can see very clearly. Now after this, after changing the sign of the expression which is written inside the bracket, I need to write the like terms together and then I will be able to get the answer or solve the. I am explaining it once again. Here what I have done, I have written this expression because I need to subtract this expression from the given expression, that is 2x cube minus 5x square minus 11x plus 2. So I have written it first minus this expression. Now this expression will be written as it is. I need to change the sign of this expression which is written inside the bracket. After changing the sign, I have written the like terms together. These two are the like terms. Likewise, I have written every like term together and I will be able to get the answer. Talking about column method, in this also we need to change the sign of each term to be subtracted and then add, like I have shown you here. This was the expression. I need to subtract this expression from this 2x cube minus 5x square minus 11x plus 2. So I have changed the sign here. You can see earlier it was of plus sign. I have made it minus. This was of minus sign. It has been changed to plus. It was minus. I have changed it to plus. So likewise you will be solving and getting the answer. Now coming to the main topic of this lecture, that is multiplication of algebraic expressions. Dear children, there are many situations. Let us have the introduction part of this multiplication of algebraic expressions. You must have seen various situations in which you need to multiply two quantities, and these quantities can be algebraic expressions. If I talk about the area of a rectangle, in this example, you will be multiplying length and breadth. And if the length of the rectangle is increased by 5 units and breadth is decreased by 3 units, then the area of new rectangle will be the multiplication of two algebraic expressions. It will be L plus 5 and B minus 3. Or simply here, if I talk about this example, whatsoever it is written here, that area of rectangle will be the product of length and breadth. These are the two quantities. And I told you that these two quantities, two or more quantities, can be algebraic expressions. If I talk about another example, suppose the price of bananas per dozen is rupees P and the bananas needed are Z in number, or Z dozens, you can say Z dozens of bananas are needed, then how much do I need to pay? It will be the product of these two, that is P into Z. This is what I need to pay. The price of bananas per dozen is rupees P. Bananas needed are Z dozens and we need to pay P into Z. If I change the scenario, like if I say the price of bananas per dozen decreased by rupees 2, new price is equal to rupees P minus 2 it will be, because earlier it was rupees P. Earlier it was rupees P and now it has been decreased by 2 rupees, so it will be P minus 2. This is an algebraic expression now. and the bananas needed decreased by 4 dozens. Earlier Z bananas were required, and now these are also decreased by 4 dozens. So new price will be Z minus 4, or bananas needed will be here. Bananas needed will be Z minus 4, not new price. It will be number of bananas needed now. Then we need to pay. How much do I need to pay? It will be P minus 2 into Z minus 4. Now I am explaining this example one more time. Suppose, dear children, earlier the price of bananas per dozen is rupees P, and the bananas needed are Z dozens. So we need to pay rupees P into Z. Now, if I am giving you one scenario that if the price of the bananas per dozen decreased by rupees 2, then what will be the new price of bananas per dozen? It will be P minus 2. And if the bananas needed decreased by 4 dozens, then number of new bananas needed will be Z minus 4. This is not the new price. This is the number of bananas needed now. It will be Z minus 4 dozens. Now, how much do I need to pay? P minus 2 into Z minus 4. And this is the multiplication of two algebraic expressions. We have seen in these two examples that we had to carry out the multiplication of two or more quantities, and if the quantities are given by algebraic expressions, we need to find their product. This is what we are going to do in this topic, that is multiplying or multiplication of algebraic expressions. That is multiplication of two or more monomials. This is the very first subtopic under this multiplication of algebraic expressions. And I hope you know that what do you mean by a monomial? An algebraic expression having only one term is called a monomial. So the product of two or more monomials can be calculated by taking first the product of their numerical coefficients and the product of their literal coefficients. First of all, I need to take the product of their numerical coefficients and then product of their literal coefficients. So let us take this first example. In this, these two are monomials and I need to take their product. So I have written them in this manner, like I need to take their product. So as I told you that to find the multiplication of two or more monomials, I need to take the product of their numerical coefficients. What is the numerical coefficient of this first term? It is 2. The numerical coefficient of this second term is minus 3. Literal coefficients, these are the literal coefficients of this is the literal coefficient of first term, and these are the literal coefficients of second term. So I have written the product of literal coefficients of both the terms. These are the numerical coefficients, that is 2 and minus 3. It is very important to understand this step because we will be using this step in few questions. Here 2 is the numerical coefficient of first term. P square Q cube, this is the numerical coefficient, literal coefficient of first term. In this second term, that is minus 3 PQ square, minus 3, it is your numerical coefficient. PQ square, this is your literal coefficient. So I have done the multiplication of these two. It will be minus 6 and these two will be multiplied. So your answer will be minus 6 P cube Q raised to the power 5. Coming to this second example, in this 3 monomials are given to you. So again we need to take the product of their numerical coefficients and then product of their literal coefficients. Here in this 3 is the numerical coefficient, 4 is the numerical coefficient of second term, 5 is the numerical coefficient of third term. PQ is the literal coefficient of first term, QR is the literal coefficient of second term, and RP is the literal coefficient of third term. So solution will be simple as I explained it. I need to take the product of their numerical coefficients and then product of their literal coefficients. So answer will be 60 P square Q square R square. This will be your product. And now coming to the subtopic, that is multiplication of a polynomial by a monomial. Now in this, multiply each term of the polynomial by the monomial using distributive law. Distributive law, dear children, we have read in chapter number 1, rational numbers, and in this, the term, what is the distributive law? In this, the term which is present outside the bracket is to be multiplied or distributed to every term which is present inside the bracket. Like, let us see now. You need to find the product of 4a and 5a plus 7ab. 4a is the monomial and 5a plus 7ab is a polynomial. So let us see now how I need to proceed. These are the steps. This is a monomial and this is a polynomial. As I told you, you need to apply the distributive law. So what you will be doing, 4a is to be multiplied by 5a first, I have written here, plus sign 4a is to be multiplied by 7ab, that is 4a into 7ab. So it will be 20a square plus 28a square b. This will be your answer. Now second example can be, you need to add 5m bracket 3 minus m and 6m square minus 13m. Let us see the steps and then I will be explaining you. First of all, you need to solve this expression. 5m bracket 3 minus m, first of all, using distributive law, this is to be multiplied by 3 first, like 5m into 3, and then minus sign 5m into m. Like this I have written here. First of all, you need to multiply and then add it to this expression. It will be 15m minus 5m square. Now adding it to the second expression, we will be getting 15m minus 5m square plus 6m square minus 13m. Solving the like terms now, these two are the like terms. What you will be getting, m square plus 15m minus 13m. What you will be getting? You will be getting plus 2m. So m square plus 2m is your final answer. Now coming to the homework part. You are supposed to complete question number 1 to question number 3 of exercise 9.2 in your homework notebook. So dear children, I am summarizing whatsoever we have learnt in this lecture number 3. Firstly, we have recalled the concepts of polynomials. Then degree we have revised. After that, addition and subtraction of algebraic expressions we have seen that in addition and subtraction we need to solve the like terms by writing. We have learned two methods like column method and horizontal method. In horizontal method, we collect different groups of like terms and then find the sum of the like terms in each group. And then in column method, we need to arrange the like terms in such a way that they are written one below the other. Likewise, we have learnt the subtraction of algebraic expressions, and then we have learnt the multiplication of algebraic expressions. Like we have seen few examples in which I told you that we need to multiply two quantities, and these two quantities can be algebraic expressions or simple quantities also. So I hope, dear children, using these concepts you will be able to cover up question number 1 to question number 3 of exercise 9.2 in your homework notebook from your NCERT book. Now let us discuss the homework solutions from NCERT book exercise 9.1. Question number 3, it is add the following. I am explaining few parts, rest parts you are supposed to do on your own, and these are easy ones, you will be able to do it easily. Dear children, we need to add these two expressions. So what I have done, I have written this expression. This is the expression I have written as it is. Then I have written this term minus 3p square q square plus 7pq plus 5. It can be written like this or it can be written in the manner as it is given in the question. But ideally you are supposed to write in the decreasing order of the powers of the variables. The way I have written it here. It is up to you. You can write it like this also. So I have solved the like terms and I will be getting the answer as 2 minus p square q square plus 4pq plus 9. Let us see the steps once again. These are the two expressions you need to add. I have written them like this. simply I have put a plus sign, or I have written this minus 3p square q square first, then plus 7pq plus 5. Ideally it is to be written like this. So I have written the like terms together now. These two are the like terms, these two are the like terms, and these two are the constant terms. So solving first two like terms, I will be getting minus p square q square. Solving these two, minus 3pq plus 7pq, you will be getting plus 4pq plus 9. This will be your answer of third part. Now coming to fourth part, I need to add all these four expressions. Let us see, I have simply put the plus sign in between, and then I have added the like terms, and I have taken two common out of these. Let us see these steps again. These are the four expressions to be added. This is the first expression, plus sign I have written, second expression plus sign, third expression plus sign, and the last expression. So after adding the like terms, I will be getting the, here L square it is present one time, this is also L square. So I have written 2L square. Likewise m square plus m square, you will be getting 2m square. These two times n square will give you 2n square, and these two are the single terms present, so I have written as it is. In all these terms, you will be observing that you can take two common. So I have written 2 outside the bracket, and this will be written L square plus m square plus n square plus Lm plus Mn plus Nl. Coming to question number 4, we need to subtract the two algebraic expressions. We need to subtract, I am taking C part, rest part you are supposed to do on your own. I need to subtract this expression from this expression. So what I have done, I have written this expression first, because I need to subtract this term, this expression, sorry, from this given expression. So I have written it first, minus first expression, and I am using here column method. You can use horizontal method also. So I am explaining the steps. I have written this first because I need to subtract the first expression from this expression, so it should be written first, minus I need to subtract this expression. I have written, dear children, you must be observing that I have written the like terms in such a way that they are one below the other. I am using column method, and this is the rule in column method. I need to write the like terms one below the other. These two are the like terms, you can see. Everywhere I have written the like terms one below the other, and these two are the constant terms. I have started from the constant term. You can write in a descending order also. I told you that you can write the expression in the decreasing order of the powers of the variables, or you can, I have written here in the first constant term, you can write it in the same manner also. And as I need to subtract, so I have changed the sign of every term. And after solving, you will be getting 28 plus 5p minus 18q plus 8pq minus 7pq square plus p square q. Thank you so much, dear children. I hope you will be able to do all the questions given on the basis of the concepts I have taught you in this lecture. So you are supposed to complete your work neatly in your homework notebook from your NCERT book. Thank you so much.